Okay, any questions? Okay, so the takeaways here is pay attention to these two formulas. They are not the same. Okay. Okay. If you have no questions, let's have a look at the next one. Next one, if you want to simplify this, we need to convert the numerator and denominator in the factored form, right? So anything in common in the numerator here? The answer is yes, because we have a common factor of 3, right? So we can put 3 in front, and what's left there is a minus 3, right? Now it's in a factored form, which is ready to be canceled with anything in the denominator. So how about the denominator? Note that there are 3 terms, right? You have something square here, something square here. Now we need to check if the middle term is twice of the square root of the first term and the last term. Apparently it is, right? So this is apparently a minus 3 square, right? And remember that you can always check back. So if you expand a minus 3 to the second, you will get a squared minus 6a plus 9, which is exactly the same as original expression, right? Okay, so this now the denominator and numerator are both in a factored form. So that means we can try to cancel anything here. Apparently we can cancel a minus 3, right? So this gives you 3 over a minus 3. So this is a whole process to solve a question like this, okay? Any questions? Okay, so let's see the next one. Next one, the logic is very similar. In order to simplify this expression, we need to convert the numerator and denominator to the factored form. So anything in common there. Okay, for the first numerator, of course, there is, which is AB, right? AB is common factor, which we can put in front. And according to the distributive laws, what's left in brackets are A plus B, right? Okay, now for the denominator, common factor is a square, b square, right? And if we put this term in front, what's left in brackets is a plus b, correct? And then you can cancel an ab here. So let's do this later. Next part, common factor is a. So put a in front, and you will get a plus b in brackets. And a squared plus 2ab plus b squared, this is apparently a plus b squared, right? Okay, now everything is in the factored form. So now we can try to cancel anything here. So AB can be canceled with an AB here. A can be canceled with an A here. And A plus B can be canceled with A plus B here. And, sorry, 1 plus B can be canceled with 1 plus B here. And A plus B can be canceled with A plus B here, right? So the final result is there is only a 1 in the numerator, and b times a plus b in the denominator. So this is our final result. Okay, did you get it? Anything? Any questions? No? All right. Let's see next one. Next one, remember that formula says x squared minus y squared is x plus y times x minus y, right? So this means we can convert the numerator here in the factored form, which is a product of x plus y times x minus y, right? Okay, how about the denominator here? Denominator y plus x raised to the second, which is actually x plus y to the second. So now we can easily cancel the x plus y here. So the final result you get should be x minus y over x plus y. This is our final result. Okay, any questions? No? All right. Question 3. Solve the following equations for x. Okay, remember that if you want to solve for x, you should put all the terms that contain x together, right? And treat anything else as coefficients. So these two terms contains x, right? Okay, so x is a common factor which we can put it in front, and what's left there is 1 minus a squared, right? And this equals b minus c. And now you want to solve for x, right? So an intuitive thought would be x is b minus c over a minus a squared, right? This is the final result. But pay attention to this. If this one is 0, you cannot use it as denominator, right? So before you use it as denominator, always remember to discuss if this value is 0 or not, okay? So pay attention to this. So we need to discuss if this value is 0. So that means if a minus a squared is 0, in that case, that means when a is positive 1 or minus a negative 1. So in this case, we cannot divide both sides of the equation with this value, right? So in this case, we need to discuss the right-hand side of the equation. So here, if a1 minus a squared is already 0, that means the left-hand side, okay, let's write it here. That is a equals positive or negative 1. That is, the left-hand side is 0, right? So in this case, if in this case, the solution depends on the right-hand side. So if b minus c is also 0, so what will happen? Okay, suppose this is R1 and this is 1.1. So what will happen? Left-hand side is 0. Right-hand side is also a 0. So no matter what x is, this equation will hold, right? So in this case, the solution is x could be any real number, right? Okay, so if the left-hand side is 0, that means a is positive or negative 1. But the right-hand side is not 0. What will happen? So that means your left-hand side is 0 and your right-hand side is not 0. So no matter what x is, this equation cannot be true, right? Do you understand? So for example, a is 1. So left-hand side is 0, right? And how about b is 3 and c is 2? That means the original equation will become x times 0 equals 1, right? So there is no solution under this circumstance, right? Okay, so when the left-hand side is 0 and right-hand side is not 0, there is no solution. Do you understand? Okay, so now we complete the discussion for the first situation, which is 1 minus a is 0. Okay, and the second situation is if if 1 minus a squared is not 0. So in this case, we can divide both sides of the equation with this number because now it's not 0, right? Okay, so in this case, x is just b minus c over 1 minus a squared. Do you understand? Okay, have a look at this. Any questions? No? Okay, please take notes if you did it incorrectly, okay? Okay, next one. We also want to solve for x, right? Okay, so we need to put the terms that include x on one side of the equation and anything else in the other side of the equation, right? Okay, so the original equation becomes a over x equals b plus c, right? And from here, we want to solve for x. Okay, before an intuitive way to solve for this is to use a cross multiplication method, right? So this gives us b plus c times x is a, right? But remember, these two are not equivalent because in the second equation, x could be 0, but in this one, x cannot be 0, right? So these two equations are not exactly equivalent. So what's the difference? The difference is you need to specify the domain here. Remember, the domain is x could be any real value, but x cannot be 0, right? Okay, so the original equation actually is equivalent to the multiplication, so cross multiplication one plus uncondition, which is x cannot be 0. Do you understand? And from here, we can then solve for x. Okay, again, we need to discuss. Okay, this is our discussion. We need to discuss whether b plus c is 0, right? Before we use it as denominator. So first of all, if b plus c is 0, what will happen? If b plus c is 0, you cannot use it as denominator, right? So the solution depends on the right-hand side. So at the same time, if a is also a 0, what is the solution there? That means 0 equals 0. So no matter what x is, this function, this equation holds itself, right? But remember that x cannot be 0. So the solution under this circumstance is x could be any real values. except x cannot be 0, right? Okay, next, if b plus c is 0, but this time the right-hand side is not 0. So what will happen here? Left-hand side is 0. Right-hand side is not 0. So no matter what x is, this equation cannot be true. So that means no solution, right? No solution for x. Do you understand? Can you follow me? Can you follow me? Okay, so how about the third situation? We have discussed if b plus c is 0, right? So the next situation should be if b plus c is not 0, right? So under this circumstance, of course, you can use it as denominator. So we can divide both sides of the equation using b plus c, right? Okay, so x here is a over b plus c, right? Are we finished? It seems we are, but remember that x could not be 0, right? Because x is a denominator, so x could not be 0. So under this circumstance, we need to discuss if x here is 0 or not. So 3.1, if a is 0, so what will happen? If a is 0, x is 0, but it is contradictory with the domain, right? So under this circumstance, there is no solution. So the last situation is if b plus c is not 0, x is a over b plus c, right? So if here a is not 0, so this is okay because when a is not 0, x is not 0. So this is not contradictory with the domain. So under this circumstance, x is simply a over b plus c, right? So this is very important. If a, b, c are concrete numbers, it is very easy to solve this actually. But if they are not, if they are just letters, you need to discuss if the denominators is or are zeros or not. Do you understand? This is a complete solution. If you only have x equals a over b plus c, this is incomplete because it did not consider whether the denominator is 0 or not. All right? I hope you can understand this. Any questions? No? All right, let's see the next one. Solve b for the solve b. Solve for b in the formula a squared plus b minus 2 squared equals c squared. Okay, if you want to solve for b, remember that we need to put anything else containing b in one side of the equation and put anything else in the other side, right? Okay, so the original equation is equivalent to, let's put anything that contains b in the left-hand side. And the right-hand side is anything else, right? Okay, now you can solve for b, right? So we know that b minus 2 to the second order equals something. That means b minus 2 is the square root of this thing, right? But remember that it can also be the negative square root, right? Can you follow me? So now you know b minus 2 is this. What is b here? B is simply 2. Positive or negative, the square root of c squared minus a squared. You understand? Any questions? Okay, now let's proceed to question 5. Solve for r in the formula m equals small n times r divided by r plus small r. Okay, here we want to solve the uppercase r, so let's put any items that contains r in one side and anything else in the other side, right? So by cross multiplication, first you will get this one, right? And then let's expand the left-hand side. Next, we need to merge that anything contains uppercase R, right? So let's put MR on the right-hand side. And this gives you small n minus big M times R equals big M small r, right? Okay, so R here is big M small r over small n minus big M, right? But strictly speaking, you need to discuss whether this value is 0, right? Because here we are using it again as denominator. So I'm not gonna do this here. You need to do this. You need to be able to do this by yourself, okay? Discuss whether this value is 0. Okay, I'll just leave this to you after the class, okay? All right, let's see the next one, question 6. Okay, evaluate a very long expression. When a is 2 and b is 1. Okay, I saw your solutions here. You just put a and b inside the expression, right? So this just seems very intuitive, but before you do that, it's better to simplify this expression first, okay? When you see a problem like this, first step is to try to simplify. The original expression. Why? Because sometimes by simplification, you will get something, okay, for example, this is a very long expression, right? But if it can be simplified to something like a plus b squared, this is very easy, right? Then you can plug these values into the simplified expression. This makes you, this will make the problem much easier, right? So first of all, let's try to simplify the very long expression here. Okay, so the first part is, okay, 4ab cube divided by 4ab, which is b squared, right? Okay, minus, okay, this is according to the distributive law, b squared minus 8a squared b squared over 4ab, right? So the second part is 2ab, right? Okay, now we finish the first part. Next, we will get 2a plus b times 2a minus b. This is actually according to this formula, right? Something squared minus anything other thing squared. This is a plus b times a minus b, right? So here we will get 4a squared minus b squared, right? And now you can see b squared can be canceled with minus b squared. So this gives us 4a squared minus 2ab, right? Okay, so that means the original expression can be simplified to this one. And now it's much easier to put these values into the simplified expression, right? So when a is 2 and b is 1, this will give you 4 times 2 squared minus 2 times 2 times 1. And this is 16 minus 4, which gives you 12 as a final result, right? Okay, so next time when you want to evaluate some expression given the values of the letters, first of all, you need to think about if you can try to simplify the original expression to make the problem easier. Okay? All right. Let's see another example, which is question 7. This is actually based on the same logic in question 6. First of all, if you want to simplify this, of course, you can just insert the values directly, right? Or you can have a look at it if you can make it to some simplified expression to make the problem easier. Okay, so let's have a look both of the method. Okay, so method 1, which we call directly insert the values. Okay, so what will happen here? You will get 1 minus 2 squared root 2 squared plus 1 plus square root 2 squared minus x times y minus 2x minus 2y, right? So basically we directly insert these values here, and a minus b to the second order, this will give you a squared minus 2ab plus b squared, right? So you will get 3 minus 2 square root 2, right? Okay, next you will get 3 plus 2 square root 2. Okay, minus, next formula is 1 plus a times 1 minus a. This will give you a squared minus b squared, right? So 1 minus 2, correct? Okay, next one, this is distributive law, right? So pay attention to the minus sign here, minus sign here. So everything inside brackets, change the sign to the opposite. So you will get minus 2 plus twice of square root 2 and minus 2 minus twice of square root 2, right? Now, can we cancel something here? So minus this plus this is 0. Again, positive, negative is 0. So these values can be canceled. So what's left there? 3 plus 3. Okay, 1 minus 2 plus 1. Because you have a minus 1, which is plus 1, right? And minus 2 minus 2. So this gives you 7 minus 4. And the final result could be 3, right? Do you understand? This is the most intuitive way to complete this task. Okay. Any questions? No? So as you can see here, if you just plug in these values, this expression will become very long, right? So is there any better method to complete this? Okay, I'll introduce method 2. Okay, so by observation, we have x squared, right? X squared minus 2x. So if we can put a 1 here, so if we put a 1 there, so x squared minus 2x plus 1, this is actually x plus 1 squared, right? And note that x is 1 plus square root 2. So x minus 1 is just the second part of this value, right? So if we can convert the original expression like this one, then we can use the formulas there, right? Okay, so let's have a look if we can do this. Okay, so the original expression, if we convert it to x minus 1 square plus y minus 1 square, what it will give us? It will give us x squared minus 2x plus 1, right? And plus y squared minus 2y plus 1, right? But remember that there is no plus 1 and plus 1 in the original expression. So we need to minus 2 to cancel these two ones. And what else are we missing? We're missing this term, right? So we need to add minus xy here. Right? So actually the original expression is equivalent to this expression, right? Do you understand? Okay, and now we can insert these values. How about the first term? First term is x minus 1, which is just minus square root 2 square plus y minus 1 is actually square root 2 square, right? And then you minus 2. And then minus x times y. And then you will get first term is 2, next term is also a 2, and then minus a 2. And then minus a plus b times a minus b, right? Which is a squared minus b squared. So this actually gives you 2. Okay, so these two cancel with each other, right? Plus 1, which gives you a 3 as the final result. And as you can see, which method is easier? Okay, you can choose either one you like, but I think the method 2 is much easier than the first one. Okay, any questions? Have a look at this. No? Can you follow me? All right, if you have no questions, let's move on to question 8. The question 8, 9, 10, 11 are actually based on the same logic. When you know a relationship between two variables. So let's have a look at this. This expression actually, okay, I'll write it here, actually gives you what? A relationship. What relationship? The relationship between A and B, right? So that means we can substitute one with another. Substitute the other, right? Okay, so we can write like this. If because A over B is 3 over 5, we can have actually A equals 3 over 5 times B, right? This means we can substitute A with 3 over 5 times B, right? Okay, let's denote this with number 1. And the original expression here is a 2. So let's put 1 into 2. Then what will happen? We get, what will we get there? A is 3b over 5, right? So A is 3b over 5. Okay, in the denominator, A plus B. A is 3b over 5. So let's put 3b over 5 here. And then plus B, right? And what you can see here, we actually substitute A with 3b over 5, right? And then why we need to do this? In this way, then we can cancel a B in both the numerator and denominator, right? Because it has a B here, and B here. So it's possible for us to cancel a B. But to make it more clear for you, let's convert the denominator to a factored form. Because remember that if you want to cancel anything, you need to change everything in the factored form, right? Okay, so in the denominator, B is a common factor. So let's put B outside the brackets. Okay, so in this way, we can cancel a B here. So what's left in the ratio is just 3 over 5 over, okay, 3 over 5 plus 1 is actually 8 over 5, right? And then you can see this is actually 3 over 5 times 5 over 8, which gives you 3 over 8, right? Can you follow me? So this is very important. Okay, so some of you solve this question in another method. I can see the logic behind your reasoning. So you think that A over B is 3 over 5, then A is 3, B is 5, right? So this is not always true because A can also be something like 9. B could also be something like 15, right? The result is still 3 over 5. So A is not necessarily 3. or b is not necessarily 5. But you can also use the logic to solve the questions. So the second method, I'll write it here. It's not very common, but it's still doable. Method 2, okay? Let's see the normal method called method 1. This is common because it's more universal, okay? Method 2, when you know that a over b is 3 over 5, you can let a equals 3k, b equals 5k. A is not necessarily 3, b is not necessarily 5, but a can be substituted with 3 times something. And at the same time, b can be substituted with 5 times something, right? As long as k is not 0. Because 1k is 0, a over b is not 3 over 5. So as long as k is not 0, a can be substituted with 3k, and b can be substituted with 5k, right? So 2 becomes a over a plus b. What is a now? A is 3k, right? And a is 3k. What is b? B is 5k, right? Okay, so the original expression becomes 3k over 3k plus 5k. So which is actually 3k over 3 plus 5 times k. And now you can cancel k, right? So this gives you 3 over 8. This can also solve a problem like this, right? So next time, my recommendation is to use method 1 because it's more common. You can always solve a problem using a method 1, but not necessarily for method 2. You can only use method 2 when the order of the denominator and numerator is the same. Okay, I'll put the note here, okay? Note. Method 2 is doable only one. Okay, let's not use a strong word only. It's doable one. The order of numerator and denominator is equal. Why? Because once the order of the numerator and denominator is equal, then you can cancel the k, right? Otherwise, when they are not equal, there will be a k left in the denominator or the numerator. You cannot cancel them totally, right? So this should be pay attention to. Okay, so let's make a start here. Always try to use the first method because it's more universal. Okay, any questions? Okay, if you have no questions, let's have a look at question 9. Actually, the logic is very similar to what we have used in question 8, right? So actually, this gives you a relationship. Let's say relationship between A and B, right? When you know the relationship between two variables, then you can use a substitute method. Substitution method is available. Right? Okay, so because A over, okay, lower my voice. A over B is 2 over 5, so we get A is actually 2 over 5B, right? Okay, then we can put this into the original expression. So let's say this expression is 1. This expression is 2. If we put 2 into 1, what we'll get? A minus 2b is actually 2/5b, right? Minus 2b over 2a. 2a is actually 2 times 2/5b, right? And then now you can see that you can cancel a b here, which leaves you only a number. Okay, let's do this later. And the second part becomes 2 times a. A is 2/5b, and times a b. Okay, next, in the denominator, you have a times b, which is 2/5b times b minus b squared, right? Okay, now let's have a look at if we can simplify this expression. So according to the distributive law, first term is 2/5 minus 2 times b, and then 4 minus 5 times a b. Okay, second part is 4/5b squared over 2/5 minus 1, right? Times b squared. Okay, everything is in the factored form, and then we can try to cancel anything here. So b can be canceled with b. B squared can be canceled with b squared, right? Okay, so what's left there is 2/5 minus 2 is minus how many? 8/5, right? And this is value then over 4/5 minus 4/5 over, okay, this one will give you minus 3/5, right? Okay, so now you will have first part is minus 2, right? Second part minus minus is plus. So plus 4/3. And then the final result is minus 2/3. Okay, any questions? Let's use separate them here. Okay. Okay, any questions? No? Okay, let's see question 10. So now you can see how we can solve question 10, right? This is also a relationship between A and B. So what does it tell you here? It tells you that A is minus B, minus 2B, right? So when you know that A is minus 2B, and then you can insert this into the original expression, right? Okay, so let's note this using a number 2. And the original expression is number 1. So let's put 2 into 1. What you will get? Because A is minus 2B, right? So the first term is 2 times minus 2b plus b. Okay, over a square. A square is actually minus 2b squared, which is 4b squared, right? Okay, minus a times b, which is minus 2b times b, right? Okay, plus 1 over a, which is 1 over minus 2b. Okay, divided by something is times the reciprocal of this, which is a squared minus b squared, which is actually 4b squared minus b squared over a, right? Okay, so now we can try to simplify. Sorry, a here is also can be substituted with minus 2b. So now we can try to simplify this. First term, minus 4b plus b is minus 3b over 4b squared plus 2b squared, right? This is 6b squared. Okay, plus minus 2b, which is minus 1 over 2b, right? Okay, then times 4b squared minus b squared is 3b squared, and 3b squared over minus 2b, right? Okay, now according to the distributive laws, we can distribute the common part in the brackets. This will give you minus. Okay, let's simplify the first term first. 3b can be canceled with denominator, right? This will leave you just 1 in the numerator. So what's left in the denominator is 2b. So this value times 3b squared minus 2b. Okay, and then plus, right? Because you have a plus sign and plus sign, this will give you a, sorry, you have a negative sign, this gives you a plus sign. Okay, 1 over 2b times 3b squared 2b, right? So this gives you, let's try to cancel anything there. So b squared can be canceled with b squared. So the first term is 3 over 2 plus, okay, here b squared canceled with b squared. And this will give you 3 plus 2, right? Okay, sorry, 4 plus 2. Sorry, not 3 over 2, 3 over 4, right? Because we have 2 here. 2 by 2 is 4. Okay, 3 over 4 plus 3 over 4, also a 4, right? So this gives you 3 over 2. This is the final result, right? Okay, did you get it? Okay, let's see the next one. Next one, the logic behind is actually the same, right? Because this is actually a relationship between x and y. It tells you that 1 over x equals 3 plus 1 over y, right? This is actually 3y plus 1, right? And this actually tells you x is y over 3y plus 1, right? And when you know that x is y over 3y over 1, you can put this in the original expression, right? Do you understand? But by using this method, you will see that the computation here will become very complex, right? So is there any better way to do it? Okay, so method one, I'll not write method one. Okay, I'll leave this for you after the class. Okay, if there is any better method to solve this question, remember that here you have 1 over x and 1 over y, right? So to solve this, if we can convert anything in the original expression to 1 over x or 1 over y, then we can use the relationship directly here. So now we can divide both the denominator and numerator using x and y. Okay, so this is actually works this way. Let's denote the numerator with an x and y, and at the same time denote the denominator also using an x and y. So what you will get here? You will get 2 over y plus 3, right? And then minus 2 over x. Then you will get 1 over y minus 1 minus 1 over x, right? Okay. Now 2 over y plus, minus 2 over x is actually twice of 1 over y minus 1 over x, right? And then plus 3. So how about the denominator? Denominator is actually 1 over y minus 1 over x minus 1, right? And then you can see that all we need to know is 1 over y minus 1 over x. Actually, this is given to you by this expression, right? So this expression tells you actually 1 over y minus 1 over x equals minus 3, right? Because when you put 1 over y in right-hand side and 1 over x on the right-hand side, at the same time, you need to put 3 on the left-hand side, and 3 becomes minus 3. So that means we can put, okay, let me denote this is number 2, and this is number 1. All we need to do is to put 2 into 1. Then we will get 2 times minus 3 plus 3, right? Over minus 3 minus 1, correct? Okay, and then this will give you minus 3 over minus 4. Then the final result is just 3 over 4, right? Okay, of course, using method 1, you can also solve this question, but method 2 is much easier than the first method, okay? Okay, if you are interested in it, you can try to solve this question using method 1, okay? I'll leave this after class for you. All right, any questions? No? Okay, let's see question 12. Find the value of a if we know that a over 6 equals b over 5 equals c over 4, and another relationship between these 3 variables. Okay, again, that logic to solve such problem is very similar to what we have learned in previous questions. So you want to solve for a, right? And you know the relationship between a and b, a and c. So that means we can substitute b and c with a in this relationship, right? Okay, so following this logic, because A over 6 equals B over 5, right? This gives you B is actually 5 over 6 times A, right? And you also know that A over 6 equals C over 4. This is actually a relationship between C and A, right? So now we know that C is 2 over 3 times A, right? Okay, suppose we denote this is 1, this is number 2, and this is number 3. Now we can then put 1 and 2 into 3, right? Then it gives you A plus B. B is actually 5 over 6 times A, right? Minus 2C. 2C, C is 2 over 3 times A and equals 6, right? And then you have an equation that involves only A, right? Anything else is gone. So from this equation, we can solve all A. So this is actually gives you 1 plus 5 over 5 over 6 minus 4 over 3A equals 6. So this means we can times a 6 to both sides of the equation to eliminate the ratios to make the problem much easier. Okay, so this gives you, okay, 6 plus 5 minus 8A equals 36, right? Okay, so this is actually 3A equals 36. So what is A here? Of course, A is 12, right? Okay, any questions? No? All right, let's see question 13. Okay, question 13, that you know the relationship between A and B. And this time there are two relationships, right? Which is 1 times B equals 1, and B is 2A minus B, right? Sorry, 2A minus 1. So actually from these two relationships, you can solve for A and B. Solve the values for A and B first. So let's try to do this. Okay, first of all, method 1. If we know that A times B is 1 and B is 2A minus 1, this is actually, you can substitute B with A, right? So we put 2 into the first expression. This will give you A times 2A minus 1 equals 1, right? And this is actually 2A squared minus A minus 1 equals 0, right? And this is actually tells you, you can factor this expression, right? Remember that by cross multiplication method, we can factor it into, okay, 2. 1 by 2 is 2, right? Minus 1 is 1 times minus 1. And then you have a negative A, so we put minus sign here. And by multiplication, by cross multiplication, we'll get minus 1 here. So the factored form is A minus 1 times 2A plus 1 equals 0, right? And then you can solve the values of A, correct? If you solve the value of A, then you can solve the value of B. If you know both values, you can then solve the expression here, right? Okay, so I'm not gonna write all of these. This solution seems a little complex, right? Okay, so there is another solution for this. Let's call it method 2. Because this time, before we solve A and B, let's solve it from this expression. You want to solve this expression, right? So this expression is actually, when you change it to a single fraction, what you will get? You will get b minus 2a over ab, right? So if you want to evaluate the value of this ratio, you need to know the numerator here and denominator here, right? And luckily, this information is given to you, right? You know that a plus a times b is 1. And also, this expression here actually tells you that b minus 2a is minus a, right? Okay, so let's call it number 1, number 2, and number 3. So if you put number 1 and number 2 into number 3, what you will get? You will get, okay, b minus 2a is minus 1. ab is 1, right? This is actually minus 1. So this is our final result. It's much easier than the first method, right? Okay. Anything you want to ask here? No? Okay. So in a summary, question 8 to question 13. The essence behind these questions are substitution method, which will be used a lot in our next chapter. Okay, so try to understand this method. All right, if you don't have any question, let's have a look at question 14. Okay, question 14, you want to find a fraction, right? And then this fraction multiplied by this one, you will get this one. So we can use a letter A to denote, or use a letter A denote the fraction you want. Okay, the reason here I use a letter A, not an X, is that because we have an X here and here, right? So if you use a letter X, it can be easily confused with the other two expressions. So it's better to use another letter, such as A or M or N, right? Okay, so this time we use a letter A. So all you know is A times 3x squared over 2y cubed equals 8y over 3x, right? Okay, so if you use the letter x here, you can see that this x can be easily confused with x here, right? So this is why I use another letter to denote the fraction you want. Okay, so you want to solve for a, right? A is actually 8y 3x. Okay, divided by 3x squared over 2y cubed, which is equivalent to times the reciprocal of this expression, which is 2y cubed over 3x squared. So this gives you a is actually 16y to the fourth over 9x cubed, right? This is a fraction you are looking for. Okay, understand? Any questions? No? All right, let's see question 15. Question 15 asks, For what value of a does equation have no solution for x? Okay, if you don't know how to start a question like this, you can always try to solve for x, right? Okay, the logic is to try to solve for x and then have a look what will happen there, okay? All right, before we do this, pay attention to the domain because you have an x in the denominator, right? If you have an x in the denominator, always pay attention to the domain. So domain here is, of course, x cannot be equal to 2, right? Except that x could be any real numbers. Okay, so if you want to solve for x, we can use a cross multiplication method, which is 5x minus a equals 2x minus 4, right? And then we need to combine all the items contains x. So this will give you 3x equals a minus 4, correct? So what is x here? X is actually a minus 4 over 3, right? This is our solution, right? And the question is, for what value of a does it have no solution for x? But apparently here we have a solution for x, right? So what does this question mean? Pay attention that our x could not be 2, right? So if you have a solution of x being 2, this will contradict with our domain. So in that case, there is no solution for x, right? Okay, so because domain is x cannot be 2. So when a minus 4 is 3 equals how much? When this value equals 2, there is no solution, right? Why? Because when this value is 2, then x will be 2, right? This is contradictory to the domain. So in this case, there is no solution for x. So that means when this value is 2, that means a is 3 by 2 plus 4 is 10, right? Okay, so in conclusion, when a is 10, there is no solution for x, right? Okay, and remember that you can always try to verify your result. Let's verify. Okay, to verify, all you need to do is to put a equals 10 into the original equation. This becomes 5x minus 10 over x minus 2 equals 2, right? And you can see that 5 is a common factor. So this gives you 5 equals 2. This cannot happen, right? So there is no solution for x if a is 10. Did you get it? So next time when you see a problem like this, if you don't know where to start, you can always try to solve for x and see what will happen there. All right? Okay. Any questions? Okay, if you don't have any question, let's have a look at question 16. Okay, question 16, you want to try to solve for the value of a, right? And you know that 2x plus 3y equals 2a, and two other relationships. Okay, so in order to solve for a, it's better for us if we can eliminate the x here and y here, right? Okay, so the logic behind this is to try to eliminate x and y. If this equation only contains a, you can solve for a, right? Okay, how to eliminate x and y? You can use these two relationships to eliminate x and y. Okay, so the question really becomes, if you know that x minus y equals a minus 5, and as well x plus y equals 3. You want to find the relationship between x and a and y and a, right? So let's denote this is number 1, this is number 2. How to find the relationship between x and a? You can use a plus 2, right? A plus 2 gives you left-hand side plus left-hand side gives you 2x. Right-hand side plus right-hand side gives you a minus 2, right? And this gives you x is actually a minus 2 over 2, right? So this gives you the relationship between x and a. So following the same logic, how do you get the relationship between y and a? So this time you want to eliminate x, right? You can use number 2 minus number 1. And this will give you 2y equals 8 minus a, right? Which is y equals 2a over 2, correct? And now you have the relationship between x and a, and the relationship between y and a as well. So let's call them number 3 and number 4. And the original expression is number 5. So if we put 3 and 4 into 5, what will happen? You will get 2x. X is actually a over 2, a minus 2 over 2, right? Plus 3 times a y. Y is 8 minus a over 2, right? Equals 2a. So now we have an equation that only a is involved. So this means we can solve this equation to get the a, right? Okay, so we can times both sides of the equation with a 2 to eliminate the ratios. So this gives us 2a minus 4 plus 24 minus 3a equals 4a, right? Okay, and then try to merge all the terms that contain a. This will give you 5a equals how many? 24 minus 4 is 20, right? Okay, of course, here we can solve a, which is 4, right? Okay, so this is our final result. All right, have a look at these questions. Be clear here? All right, I'll upload the teacher's notes into a Google Classroom for you to refer to after the class, okay? I'll put it here, lesson 90, teacher's notes. This one. Okay, and I'll put the next assignment later today or early tomorrow. Remember to download them and submit them on time, okay? And if you don't have any questions, you can leave the class. Have a nice weekend.